Hello, my Calc 2 student. Today we start a lecture. Today we start study our Calc 2 class. I hope you feel comfortable with this kind of education method. And today we talk about natural logarithmic function. How you remember? Integral, integrals x to the power n dx equal x to the power 1 more n plus 1 over n plus 1 plus c. And this is true for any n except -1. And this is work very well, but now question, what happened if our variable is -1? And here we have some new definition. We define new function. Let's check. We call this function as natural logarithmic function, ln, and use symbol ln x if it will be integral from 1 to x 1 over t dt. Okay, what kind of information we have about this function? And first, sorry, I forgot about x need be greater than 0, strong greater than 0. What kind of information we have about this function? This means if function fx is natural logarithm x, this means we have derivative this function, who is equal 1 over x, second derivative this function, who is minus 1 over x squared. Because this is x positive here, for our definition, we can see x is positive. This means we see first derivative will be positive. This means function increased. And second derivative is always negative. This means we see what kind of concavity we have. Okay, if you remember what is mean integrals, if I'm plugging my function x, y, and this will be y equal 1 over x. It's okay, you believe me, it's got to close to. Okay, this is put point 1. And if x greater than 1, something x here, this means natural log x, it will be this area. How I can build? Okay, I plug it's area 1. This is area 1. If x lower than 1 but still is greatest than 0, this means still is positive, then I use some different color. Natural logarithm x this situation, it will be, if it's area A2, it will be negative A2, because we have integral from 1 to x, and because we have integral border is from bigger to smaller, this means we need to take it opposite. Okay, great. Now we have some couple of more information about this function. First, you can easily see in definition it's natural log from 1, it will be 0, because it's integral from 1 to 1. Any kind of function give you 0. If you border, your integration is c. And then we have natural log a times b, it will be natural log a plus natural log b third natural log a to any power n. It will be n go to front and natural log a, and fourth natural log a over b. It will be natural log a minus natural log b. Well, how you remember, this is all what we used before. And now we have some new information. It's called, we can like, it's like theorem. If you try found derivative from natural log x, it will be 1 over x. This equation, this formula come from definition natural logarithmic function. B, if you have inside natural log some function u, then use chain rule. We can write as like u prime over u. See some examples. For example, my function is natural log 5x. What will be derivative here? Remember, we need what you have inside natural log. It's go to denominator, go to here. It will be 5x. And numerical, it will be derivative your denominator. It will be 5. And it's mean 1 over x. Okay. If you have something more complicated, this is, let's go example A, example B. Let's go my function fx. It will be more complicated. For example, it's natural log from fraction, where is numerical x squared plus 1 third, divide by square root 2x to the third minus 1. For found derivative, we can found derivative without any simplifying, but it takes so much time, and because it's some difficult algebra we need to use there, I think it's make it more chance of take more mistake. What we're doing here, first time simplified my function. How you remember, if you have a logarithm product is sum logarithm, and logarithm's fraction is differ to logarithm. Remember this two formula, and remember what happened. If you have n power there, we can use and rewrite. Here we have natural logarithm x plus 3 times natural logarithm x squared plus 1 and minus 1/2. Because we have root here and mean power is 1/2, natural log 2x cubed minus 1. After we simplify in this way, found derivative is not problem. Derivative will be derivative natural logarithm x is 1 over x. Derivative here is 3 times. Denominator is x squared plus 1. And numerical is derivative, it means 2x minus 1/2. Denominator is 2x cubed minus 1. And numerical is will be 6x squared. A little bit simplified, we have our derivative. It will be 1 over x plus 6x over x squared plus 1 and minus 3x squared over 2x cubed minus 1. I think it's good enough, and we not spent time for simplifying or doing one fraction. Okay, one more example. How we can use logarithm for found derivative for a function that doesn't have any logarithm. For example, new example, what we have here. Our function is something like this, x minus 2 square over square root x squared plus 1. I can take it. I can found derivative. It's right now. It will be, we use a rule about fraction. We have its roots here and product and anything and chain rule because we have product and rule inside root. But we can do it much easier. Take a natural logarithm for both sides our function. Here we have, first we have x is not equal to. Okay, we have natural logarithm y equal natural logarithm x minus 2 square over square root x squared plus 1. Use property of logarithmic function. We can write its natural logarithm y equal twice natural logarithm x minus 2 minus 1/2 natural logarithm x squared plus 1. Oops. Okay. And now, found derivative this identity, I have y prime over y. It will be 2 over x minus 2 minus 1/2. Denominator it will be x squared plus 1. Numerical it will be 2x. Oh, this 2 and this 2 cancelled. This means my derivative equal, I need multiply both sides for y. But I need to remember what is y is. Y is fraction. X minus 2 square over square root x squared plus 1 multiplied by, differ to fraction, 2 over x minus 2 minus x over x squared plus 1. And we found our derivative. This is depend for what you use this derivative. Maybe you need simplify, maybe, but derivative we found. You see, it's much easier than we think before. Okay, okay, some more examples. But before we start working, what happened if you have, here we have some theorem. What happened if you have inside logarithm absolute value? How you can find derivative? It's now theorem say derivative function is natural logarithm absolute value u. It will be u prime over u. This means u not, this is absolute value is not important for found derivative. Okay, how we can prove this fact? If you have absolute value u, this means you have two possible situations. U is positive, u is negative. A, u is positive, but mean natural log absolute value u, oops, it will be exactly natural log u, and this means you have derivative absolute value u. This is not the absolute value. This means you use chain rule, and what we used before, it will be u prime over u. Okay. B, u is negative. This means natural logarithm absolute value u, you need take it opposite u. This means we have absolute value 5, it's 5. Absolute value negative 5 is it's still 5, but this means minus negative 5. And to use this fact, we're doing differential natural logarithm from negative u, and use formula for found derivative. You have minus u prime over minus u. This is 2 minus cancelled, and you have u prime over u. Oops. Okay. See some example. Example. I need found derivative function fx if its fx is natural log absolute value cosine x. Okay, this means derivative will be found derivative, it will be denominator, we go to what we have inside without any absolute value, it's mean cosine x, and numerical is derivative, denominator is minus sine x. It will be negative tangent x. That's it. I think we're ready for use our skills for found derivative logarithmic function, or for example, found relative extreme. Let's go. Example, I have function y equal natural log x squared plus 2x plus 3. Well, first you remember, inside natural log it can be stay only positive numbers. But if you have x squared plus 2x plus 3, it will be x plus 1 square, who give me x squared plus 2x plus 1, and that's left over 2 plus 2. Here I have something not negative and plus something positive. This means strong greater than 0 for any x. More accurately say it's greater than 2 for any x, but okay, we need for greater than 0. Okay, now we found derivative. This means what I'm checking first. Sorry, I am skip. I'm check my function have domain x is from negative infinity to positive infinity. This means function exists for any x. Okay, found derivative. What we have here? How you remember? X squared plus 2x plus 3 go to denominator, and numerical it will be derivative, it will be 2x plus 2 twice out, x plus 1 x squared plus 2x 2x plus 3. Denominator here doesn't have any zeros. This means derivative function exists for any x, and for x equal negative 1 is equal 0. This means if we build some axes and information about derivative, and this is information about function, one point make it derivative is 0, it's negative 1. If x is greater than negative 1, you have positive derivative. If x is less than negative 1, you have negative. It means your function is decrease and then increase, and mean negative 1 is relative minimum. Okay, how we can use our derivative. One more type of example. We need found equation of tangent line. Let's go. Our function is 4 minus x squared minus natural log 1/2 x plus 1. And we have point 0, 4. Point where we need found tangent line. Okay. First we need found slope. Slope is how you remember is value your derivative for given point. But first we need found derivative. It will be 4 minus x squared. This means minus 2x, and natural log give me minus. Here we have 1/2 x plus 1. This one we have numericals will be 1/2. And value derivative for point 0, because x is equal 0 here. For our given point, it will be negative 1/2 divided by 1. It means negative 1/2. Okay, and now I'm ready for write my equation, my tangent line. It will be y minus value 0.04. This means y minus 4 equal slope negative 1/2 x minus value x for your point. That means 0. It means here we have final answer negative 1/2 x plus 4. This is equation our tangent line for given point and given function and given point. Okay. One more example. When we remember how it means found, use implicit derivative, found derivative of function. It's happened if you don't have exactly equation for how y depend x. You have some equation who show you relation between y and x. For example, here we need found dy dx, question mark, if we have this kind of equation, natural log xy plus 5x equal 30. Great. Well, here we can find now, or I think it's better if a little bit simplify. This means natural log product xy we separate. It will be natural log x plus natural log y plus 5x equal 30. Found derivative here. Remember y is function depend x. X is independent variable. This means here we have 1 over x. Use chain rule. Natural logarithm y derivative, it will be y prime over y plus 5, because derivative 5x is 5, and derivative constant is 0. This means here you have y prime equal y times minus 1 over x minus 5. Or I write y prime, I can write dy dx, exactly what they ask us. It's only different way for writing. Okay, that's it. This is all about section 5.1, and now you can practice doing homeworks. And remember, end of week we have quiz. Oops.